Hello everyone, I hope you are doing well. Today we are discussing in this topic the Python for forensic because Python is one of the most popular programming language for beginner friendly and in the world right now it's used everywhere from web development and automation to data science, machine learning, AI, scientific computing, game development, and DevOps, and even finance and cybersecurity. Let us begin with start this topic. Uh, Highlight topic to show you. We will discuss about an introduction to Python and healthy development practice, basic programming concept, manipulating and storing object in Python, creating simple conditional loops and functions. Today, Python 3.14.3 is the latest stable release. When to use Python? Python is a powerful forensic tool. However, before deciding to develop a script, it is important to consider the type of analysis and that's required and the project timeline. In the example that follow, we will outline situation where when it is not worth the development effort. So a rapid development make it is easy to deploy a situation in solution in tough situation. Python is not always the best tool to implement. If a tool exists that performs the task at hand and is available, it may be the more appropriate method for analysis. Preferred programming language for forensic. Its ease of use, library support, detailed documentation, and interoperability among operating system. There are two main types of programming language: those that are interpreted and those that are compiled. Compiled code allow the programming language to be converted into machine language. This lower level language is more efficient for the computer to interpret. Interpreted language are not as fast as compiled language at runtime, but do not require compilation, which can take some time. Because Python is an interpreted language, we can make modification to our code and immediately run and view the results. With a compiled language, we would have to wait for our code to recompile before viewing the effect of our modification. For this reason, Python may not run as quickly as a compiled language, but allows for a rapid prototyping. An incident response case present an excellent example of when to use Python in a real-time setting. For example, let's consider that a client calls panicked reporting a data branch and is unsure of how many files were exfiltrated over the past 24 hours from their file server. Once on site, you are instructed to perform the fastest count of file accessed in the past 24 hours, as this count and the list of compromised file will determine the course of action. Python fits this bill quite nicely here. Armed with just a laptop, you can open a text editor and begin writing a solution. Python can be built and designed without the need for a fancy editor or toolist. The build process of our script may look like this with each step building upon the previous ones. First, make the script read a single file, last access timestamp. Second, write a loops that set up through directories and subdirectories. Third, test each file to see if that timestamp is from the past 24 hours. And fourth, if it has been accessed within 24 hours, then create a list of affected files to display live path and access times. The process here would result in a script that records over the entire server and output files found with a last accessed time in the past 24 hours for manual review. This script will likely be approximately 20 lines of code and have required 10 minutes or less. For an intermediate scripter to develop and validate, it is apparent this would be more efficient than manually reviewing timestamp on the file system. Before deploying any developed code, it is imperative that you validate its capability first. As Python is not a compiled language, we can easily run the script after adding new line of code to ensure we haven't broken anything. This approach is known as test then code, a method commonly used in script development. Any software, regardless of who wrote it, should be scrutinized and evaluated to ensure accuracy and precision. Validation ensures that the code is operating properly, and although more time consuming, provide reliable results that are capable of withstanding the courtroom and important aspect in forensics. A situation where Python may not be the best tool is for general case analysis. If you are handed a hard drive and asked to find evidence without additional insight, then a pre-existing tool will be the better solution. Python is invaluable for targeted solutions such as analyzing a given file type and creating a metadata report. Developing a custom all-in-one solution for a given file system requires too much time to create when other tools, both paid and free, exist that support such generic analysis. Python is useful in pre-processing automation. If you find yourself repeating the same task for each piece of evidence, it may be worthwhile to develop a system that automation those steps. A great example of suite that performs such analysis is a main-tech analysis and triage system, which leverage a series of tools to create general report that can speed up analysis when there is no scope of what data may exist. When considering whether to commit resource to develop Python script either on the fly or for larger project, it is important to consider that solutions already exist, the time available to create a solution, and the time saved through automation. Despite best intentions, the development of solution can go on for much longer than initially conceived without a strong design plan. I hope you are like this topic. If you have any question, keep mention in the comment box. Thanks a lot for watching the video.